Okay, once you've downloaded the starting files from GitHub, this is what you will see. So you see I've set up your game area here, and there's a ball in the middle. Not everything here is done. If I click on play, you'll see that the ball bounces off this side, but not off there. So this side, and this side are not set up properly. I'll leave you to that. There's no paddle down the side. One thing I will point out is that when we click on this, you'll notice that the material here, which is something new, it's a physics material, not a visual material like these, physics material. So all I've done is turned off the friction and set the bounciness to 1, which is the maximum. So anything that you place on the screen, you're going to need to apply this bounciness. So on the left wall, you see it's got bouncy there. If I click on another wall and I added the collider, in here, all I need to do is drag that into there. Yep, and that'll set so bouncy. We need that, otherwise the ball will hit it, but because of physics, if there's no bounciness, it kind of just rides along the wall. So the ball would hit there and then ride along. I can show you what would happen if I go on the left wall and I delete the bounciness and now click on play. See, the ball just rides along. So you need to make sure that you include the bounciness. Alright, script. I've given you 3 scripts here. The first one is the game manager. It's there, but there's nothing in it. I'd ask you to put your name at the top. Delete the teacher who's not your teacher. So in Mr. Monk's class, like so, and then write a description of the file, and then work on this. The other files that are there, there's the paddle movement file. None of these are associated with any objects. The only reason I've kept this in here is this is the code that you're going to use to move the paddle. The reason we're going to use this code, not the regular code, is that when you create the paddle, I suggest that you set it as a kinematic object, which means kinematic means that physics forces don't work on it. The reason that we do that is though that when the ball hits your paddle, it bounces off at the same strength as a wall. If you have it as a regular object, i.e. without kinematic set, when the ball hits it, it still bounces off and it looks okay, but it actually, because they're both physics objects, the ball and the paddle actually absorbs some of the impact and it changes the angle slightly. So what I want you to do is set the paddle as a kinematic and then use this code to move it. And the last script there is ball movement. This is mostly done. So put your name once again on the top of it, get your teacher. I've kind of done the description there. Alright, so going through here, we've got the speed variable, which is public, so you can set it within the Unity console. By default, it's on 10. You've got your rigid body there, so we can access it down there, get a reference to it. This is the horizontal and vertical movement. Vertical, spelled wrong. Vertical movement that your ball will start with, and this here takes those values and builds a 3-point vector from that, and then adds that force to it. So obviously the y value is the y value is 0 because we don't want any upward movement on the ball. And then we apply the movement. However, something that's a little bit new, in the fixed update, we want to run this line of code every time it runs fixed update. What that does is it takes the current velocity of the ball and normalizes it. What normalizes means is it makes it a vector length of 1. So it kind of standardizes it. Yep, so it doesn't matter what speed the ball is going, this will just basically return the direction. Okay, so if it was going straight up, it would be 0, 0, 1. If it was going straight right, it would be 1, 0, 0, etc. And if it's in between, each one of those vectors would be a length of 1. So if it's going off at a 45-degree angle, it wouldn't be 1, 0, 1 because that vector would be longer than 1. It would be, I'm not sure, 0.80 0.8. So the vector itself would be a length of 1. This enables us to do is, since it's standardized, we can then multiply it by speed and make sure set the velocity as that speed, so that the ball always moves at the same speed. It never slows down. I did try and play around when I was creating my prototype, setting up these bounce values exactly right so the ball would never slow down. However, it always eventually comes to a stop. Sometimes it takes a long time, but it does come to a stop. So I found that by doing this and the fixed update just guarantees the ball always moves at the same speed. It also allows you some flexibility if you decide to do certain power-ups. And that's what we've been given. So good luck with the assessment, and I hope it all makes sense.